Hey folks, this is Wednesday's class, Economics 2620. We're getting back into Chapter 3, and Chapter 3 covers valuing benefits and cost. So the outline of this chapter begins with a conceptual discussion of the types of environmental values that might be used in a benefit cost analysis. And then we talk about how to estimate those values, put a dollar value on those. And these are called non-market valuation methods, and there's two broad classes of non-market valuation methods. There's revealed preference methods and stated preference methods. Then we'll talk about some issues within those valuation methods. One of the biggest is estimating the value of statistical lives, and then we'll talk about benefits transfer. That's used a lot for policy analysis when there's not enough time or money to use a revealed preference method or a stated preference method. Then we'll talk about estimating costs. There's two main types of cost estimation methods: a survey method and an engineering method. We'll talk about some examples of valuation of environmental and natural resources. Two that I'm just putting these here as reminders that I'm hoping that we'll be able to cover is a study about the Southern Appalachian Mountains by Banzaf et al. And a study looking at the BP Deepwater Horizon Natural Resource Damage Assessment by Bishop et al. That came out last year. And then we'll talk about two other types of project analysis. Cost effectiveness analysis is used sometimes when you cannot estimate the benefits in monetary terms. And then we'll talk about economic impact analysis. So there's several things we need to remember as we go along. The graph on the right is one that you've seen several times. So we are looking to estimate the benefits underneath this demand curve. So all this area, that triangular area that y'all have calculated over and over again, we're going to try to estimate what those dollar values are. Okay, and we're not doing environmental science in this class or epidemiology, so we're going to assume that physical damages have already been estimated. These are things like health and the ecological impacts of a policy. Okay, and once those physical damages are estimated, that's when this chapter becomes part of environmental analysis. So we're going to place a monetary value on those physical damages. And we'll talk about this along the way, but assigning monetary values to the environment is a complex process, and it's also controversial. So those are just some things that keep in the back of your mind as we talk about these concepts of environmental value and these methods. Okay, so there's several types of environmental and natural resource values, and just remember when I say values, these are the benefits of environmental quality that we'd plug into a benefit cost analysis. Okay, so the textbook has a classification of these concepts, and the ones that I'll talk about in the lecture are similar. I just want to point out the differences. So The textbook talks about total willingness to pay, and that is composed of use value. The book talks about how some use values are passive use values or non-consumptive. The book talks about option values and existence value. And the total value, the total willingness to pay, is equal to the use value plus the option value plus the existence value. So I think about these values in a slightly different way, or at least the accounting process of adding up these values in a different way. So I'm going to talk about total value as being synonymous with total willingness to pay. Total value includes use value, where there's consumptive and non-consumptive use values. And then there are existence values. And these existence values are also known as non-use values or passive use values. And in my accounting of these values, existence, non-use, and passive use are all synonyms. They mean the same thing. Okay, but we do need to talk about different motives for existence value, and those include option, which is the same option. This option motive leads to the same option value as in the textbook's framework. There's altruistic and bequest motives and ecological motives. And then the total value is the sum of the existence and the use values. Okay, so use values is the willingness to pay for any sort of direct use of the environmental resource or the natural resource. So there's two broad classes of use values. One is recreational use of natural resources, and the other is health. And in terms of U.S. environmental policy, a lot of the benefits that flow from the Clean Water Act are recreational use values, primarily fishing, and to a lesser extent boating. Most of the benefits that flow from the Clean Air Act are health benefits. Okay, these use values, you can think of these things as anything that involves your senses. So consumptive use values include deer hunting, trout fishing, drinking water. These are all things that we experience firsthand. Non-consumptive use values, or back to consumptive, these are all things that we experience firsthand and we extract something from the environment. So if you catch a fish, take it home, that's a consumptive use value. If you're drinking clean water, that's consumptive use value. Non-consumptive uses are things that you experience firsthand, involves your senses, but you do not extract something from the environment. Okay, so you experience noise pollution by hearing. You may also experience other types of pollution through foul smells. You might see a grizzly bear in the wild. You might swim in the ocean or hike in the woods. Okay, and none of those have you taken something from the environment. Have you consumed the environment? Have you used it up? Okay, the second category of values that we're going to try to estimate are existence values. And these represent a willingness to pay to preserve a resource that you might never use, might never experience firsthand. Okay, so a couple examples. You might have a willingness to pay for protection of an endangered species. For example, loggerhead sea turtle. Okay, you might like to see a loggerhead sea turtle someday, but they're reclusive animals. The moms lay eggs up on the beach at night, and they swim around the ocean. It's rare that someone sees these things, even when they're trying to. You might have a willingness to pay to avoid an oil spill in Alaska or the Gulf of Mexico. Two examples that we'll talk about are the Exxon Valdez oil spill in Prince William Sound, Alaska, in 1991, I think, and the Deepwater Horizon oil spill 20 years later in the Gulf of Mexico. Many of us didn't experience these oil spills firsthand, but we might have a willingness to pay to avoid them. Okay, so that willingness to pay would be an existence value. Okay, so the motives for existence value, you might wonder why someone would be willing to give up some money or time or any of their resources. Why someone would want to do that, even if they don't have direct experience with the resource. So there can be all sorts of motives, but four that I think are important. There's an ecological motive, and that's when you have a willingness to pay to preserve something for the sake of the environment. You just want to know that the ecological system is sound and there's no break in the chain of the ecology. Okay, you might have a willingness to pay for someone else's utility. That's known as an altruistic motive. Okay, so even though I have never seen a loggerhead sea turtle, I know that some people are out there and they do, and so I want to I enjoy knowing that their utility is higher, their happiness is higher because of that resource. A bequest motive is an altruistic motive for future generations. So I want to protect loggerhead sea turtles so that maybe my kids and grandkids have a chance to see them someday. And then an option motive, this is the same concept as option value that's in the book, is a willingness to pay for the chance that you might demand the resource in the future. You might want to experience the resource in the future. So I've never seen a sea turtle, but someday I hope to be on the beach and be walking around at night and see one drag up on the beach and lay some eggs. So that's an option motive. Okay, so it's possible to put dollar values on use values and existence values. This is a graphic that's in the textbook, and it divides up valuation methods into two classes: revealed preference methods and stated preference methods. And then the book divides those into direct and indirect approaches. And we're not going to worry about the direct or indirect approaches. We're just going to lump all these together and talk about how these things work. So I'm going to talk about, I think first is the averting expenditure approach. Then we'll talk about the travel cost approach, hedonic property value and hedonic wage approach. And then we'll talk about stated preference approaches that include contingent valuation, contingent behavior. Let me type that in here, see if I can do that. Contingent behavior. That's not pretty, but I was able to do it. And then we'll talk about choice experiments, and those things go by various names. Some people call that conjoint analysis. Some people call it contingent valuation. Sorry, contingent ranking. There's also goes by attribute-based models, and best-worst analysis, which isn't on this list. But we'll talk about three main types of stated preference approaches: contingent valuation, contingent behavior, and choice experiments. So, reveal preference methods. These are based on actual, observable choices made by people and goods or services purchased by people that have market prices. And there's the word direct is still left in my slides, and ignore that. Okay, so the idea here is that a loss in value as a result of some sort of change in the environment can be pretty easily calculated if there are market prices that we can observe. For example, so the averting behavior approach requires expenditures be estimated, or requires expenditures that are not made if someone is faced with an environmental health risk. Or on the other hand, averting expenditures is money spent to try to avoid an environmental health risk. So imagine that in Boone there's some sort of water contamination episode, and the town of Boone, as they occasionally do, tell us not to drink the water that comes out of the tap. So people might run out to the grocery store and buy a crate of bottled water, and the money spent on that bottled water is considered an averting expenditure, and that would be an estimate of the benefit of a policy that reduces the risk of a water contamination episode. And there's the word indirect that I left in my slide, but don't worry too much about that. Okay, this other type of reveal preference methods use markets that are related to the environment to infer a value, and that's where the term indirect comes from. Okay, so for these methods, we observe people spending money or doing things in these surrogate markets, and we're able to extract out the environmental value of that good. Okay, one type of reveal preference approach is the travel cost method. And this is primarily used for outdoor recreational resources. And what you do is figure out how much money people spend getting to a recreational site. And then you can use that along with the number of visits that they make to the site to estimate a demand curve. The hedonic property value, and to a lesser extent hedonic wage approach. But this one we use statistical analysis to estimate the value of a house or your job that's associated with the environment. So for example, property values are lower in places that have a lot of air pollution. Or property values, a housing price is lower if it's located near a hazardous waste facility. So the hedonic property value approach uses the difference in those prices to estimate the value of avoiding the air pollution or the hazardous waste facility. Now, on the other hand, you can estimate the value of other types of amenities, like living in a place with a nice view. A nice view can add a lot of money to a house, a housing price. So, just to give you an idea of how the travel cost method might work, and we're going to, let's see, so at the top says travel cost, and the bottom of this graph says visits to the recreation site. So I'm going to leave it here. So the travel cost method, you have to collect data and ask people questions about how far they live from a recreation site. That's plotted over here on the vertical axis. So distance in miles, and this would be round trip distance. It goes from 0 to 1200. Actually, let me back up. So this is one-way distance from 0 to 1200 miles. And the visits to the recreation site are on the horizontal axis, and those visits go from 0 to up to 120 visits a year. So these dots represent people's answers to the question of how many visits they take to the recreation site each year. And then you can ask people how far they live away from the site, or you can get their zip code and calculate zip code distance. So here we have someone who lives 1,200 miles away from the site. They don't take any visits. And here's someone who lives 1,000 miles away. They don't take any visits. But once distance goes down to about 900, we have people who take, it looks like about 10 visits a year, and some people one person takes about 18 visits a year. And it looks like as distance falls, the number of visits increases until we get to someone who lives about 50, 100 miles away, and they take almost 120 visits. So the idea here is that the farther you live away from a recreation site, the greater the cost of getting there. And so we use basic economics, that as the cost of something goes up, you do less of it. Okay, so statistical analysis can then be used to fit a line that summarizes those data points. And so here we have this gray line, and it looks an awful lot like the theoretical demand curve that we've been drawing. And that's true. So what you can do is convert the distance to the recreation site to a travel cost, hence the name. Sorry about that. Travel cost method. Okay, and we'll talk about how to convert distance to a travel cost another day. Okay, so then there are stated preference methods, and these use surveys to elicit willingness to pay. Okay, so one type of stated preference method is known as a contingent valuation method. And this is an approach where respondents are asked what value they would place on some level of environmental change. It could be anything, going from the risk of an illness, from avoiding air quality or air pollution, to the loss of wildlife habitat. You can value recreational resources. You can value just about anything with stated preference methods. Then a choice experiment is a type of a stated preference question that has multiple levels of different attributes. And then survey respondents choose between different states of the world. And this is also known as conjoint, contingent ranking, best worst, attribute-based methods. Goes by a lot of different names. The third type of stated preference method is known as contingent behavior. This is a question where you ask people how they would behave in different situations. So if we go back up to, oh gosh, if we go back up to the diverting behavior approach, you can ask people how they would behave in a water contamination situation. So in that case, you'd be using a combination of a reveal preference approach, averting behavior, along with the contingent behavior, a stated preference approach. You can ask people about how many recreation trips they would take in different situations and combine the revealed and stated preference approaches. And yeah. So you folks have on over spring break, you did an exercise, a survey exercise, where you were exposed to a contingent valuation method survey question. So question 16 in the survey was, would you vote for or against having your senators support ratification of the International Climate Agreement if the increased energy taxes cost you the following amounts each year? So you were led through a survey exercise where you were asked a bunch of questions about climate change and who should pay for climate change and how it should be paid for. And then that leads up to the hypothetical / stated preference question, where you could have voted for the policy in this advisory referendum at different cost amounts. So with data like that, different for votes or yes responses and different cost amounts, this is also known as bids, you can estimate a demand curve with those data. And this is a survival probability curve associated that plots the percentage of for votes that goes from 100% up here at 1 to 80%, 60%, 40%, 20% to 0, all the way down to 0%, and plots those against the bid or the cost amount. And in this graph, the cost amounts range from $0 to $50. And each of these notches on this Turnbull, named after a statistician, each notch of these is where the bid occurs. So the lowest bid is $5. And then when the cost is $5, it looks like about 70% of the survey respondents said they would pay that cost. When the bid increased to $10, the yes responses fell to below 60%. When the bid increased to $30, well, the percentage that said they would pay for it is about 50%. And then when the bid increased to $50, the percentage that said they would pay for it is 35% or so. Okay, this Turnbull demand curve is considered a lower bound way of estimating willingness to pay because it plots those percentages, percentage for or yes, and the cost as a step function. Okay, it's just the stair step down, and then the demand curve is truncated at the highest bid amount. Okay, and one thing about the Turnbull, it's usually plotted with the bid amount, the exogenous variable or the independent variable in this analysis on the horizontal axis, and then the probability, which is the dependent variable or the endogenous variable on the vertical axis. And this is the way we do it in math. So this would be on the horizontal axis y, the y variable, and on the vertical axis the y variable, and on the horizontal axis the x variable. In economics, a lot of times we turn that around, and you saw that when we did the travel cost method graph, where we put the cost amount on the vertical axis and then the choice variable, the number of trips, on the horizontal. Okay, so that's the Turnbull survival curve. Another way of estimating willingness to pay with that type of contingent valuation data is with this Christrom approach, named after an economist who came up with this about 25 years ago. And here we have the same data plotted, but the step function is turned into what looks more like a demand curve. Okay, so let's go back to the Turnbull. Oops, go back to the Turnbull and see if I can draw on this a little bit. Okay, so the Christrom approach connects the dots. So it assumes that if the cost is 0, then everyone's going to want to pay for it. So if we connect our probability of yes or a for vote at 0 of 100% to a probability of yes or for at $5 at 70%, and keep doing that, then this red line is the Christrom survival curve. Okay, and the Christrom approach, instead of truncating, or one way to do it is by truncating at the highest bid amount to be conservative with cost amounts above the highest one that you present to respondents. Or you can extrapolate the cost out to, out to the future. So let's see. There it is. And the way it's done in the next slide is by taking the slope between the two highest cost amounts and just pushing that line out to where it intersects the horizontal axis. So that's the Christrom demand curve. Okay, so here is the results from the survey that y'all did over spring break. So again, the question is, would you vote for or against having your senators support ratification of the International Climate Agreement if the increased energy taxes cost you the following amounts each year. So in this graph, this is a graph that is downloaded from SurveyMonkey, and the green area represents or plots the 4 votes. Here we have the bid, or the higher energy taxes down here on the horizontal axis, ranging from $100 to $2,400. And on the vertical axis we have the percentage of people who say they would be willing to pay those higher energy taxes. So when the higher energy taxes are relatively low, 100 bucks, about 90% or so of you all said that you would pay that amount. And then as the cost rises, you see that the percentage that we would pay falls to the point where it goes almost down to 0. I think that's about 5% at a cost of $2,400. Okay, so the green area, the green shaded in area, would be my estimate of the class's willingness to pay for that climate change policy. Okay, so another type of stated preference question is the choice experiment. And this is an example from the textbook. This is at least table 3.2 in maybe your edition of the book. And this is an example of a Maine forest harvesting choice experiment. And here they're calling it a conjoint analysis. So there's several attributes that are in the choices that are presented to respondents. So people are presented with different forestry management plans, and they're described different levels of live trees after harvesting. And so one situation that people might be faced with are when there are no trees at all, so it's a clear cut. And then they're faced with situations where there are more trees remaining after the timber companies are allowed into the forest, 153 trees per acre, or 459. And they're described how many dead trees are left in the woods after harvesting. So these are left there instead of hauled off. And I guess the best scenario would be if all those are removed, and then there's 2 other scenarios where 5 and 10 trees per acre are left. And then respondents would be described or presented with the percentage of the forest that is excluded from logging. And that would be, the levels would be 20%, 50%, and 80%. And this is what the question looks like. So in this first column are the 3 attributes that people are described. And then the last attribute is a tax amount. And the remaining columns are different alternatives. So these are labeled A, B, C, D, and E, where alternative E is the status quo, where there's no change in the management of the forest. And then for alternatives A, B, C, and D, people are presented with randomly assigned levels of the different attributes. So, for example, alternative A is a clear-cut scenario where there's no trees remaining. All of the dead trees are removed. 80% of the forest is set aside from logging. So that means 20% of the forest is clear cut, and then the tax associated with that alternative is $40. And then the survey respondent would review alternative B, C, D, and E, and then would vote for one and only one of these alternatives. So if you preferred no change to the current policy, you would check the box associated with alternative E. If you preferred alternative A, the clear cut with 80% set aside, you would check that box. And we'll pick up with the remainder of Chapter 3 the next time we meet in person or online.